Hey, what's up? Jason here from Unity3D.college. Yesterday, I saw my daughter playing a mobile game that seemed pretty interesting, and I wanted to try recreating it. Now, I don't normally play a lot of mobile games myself, tend to be more on the PC or console or virtual reality. But this one stood out as something interesting, and it had my daughter interested, and she never plays video games. So I thought, what the hell? Let's give it a try and see if we can recreate it. And it's this Ballz game. Essentially, you grab, you drag, you shoot balls, and you break these bricks. And then every time it finishes, the bricks move down, you get some new ones. And then there's a way to unlock more balls in the other game. I just made it so that every time I go through, I get another ball. There was a target, I think, that you would hit to unlock balls in the one that she was playing. But anyway, I think you can kind of see the functionality here. It's pretty simple, but it's a pretty fun little game. And if they get to the bottom, you lose. So you basically just got to keep hitting them until they... Or to stop them from getting down and catching up to you. And then it just progressively gets harder. I just made it slowly level up and ramp up. So what I'm going to do today is just kind of run through the whole process of building this in a semi-clean way. You can see the hierarchy is not perfect right here. We clean it up a bit. But the code is generally relatively clean, and it's pretty simple to build. So let's get started. All right, we've got an empty project here, and we have a few things that we need to create. I want to start with the ball. So to create the ball, I'm going to go to Game Object, 2D Object, and just create a sprite. I'll name it Ball. And then we're going to change the sprite. I'll just click on the little search thing right there and choose the knob. It's just a nice, perfect circle. If I hit W and go to the Move tool, I can move it around and get an idea of what that thing looks like. It's kind of under the camera, so you couldn't see it before that. So there's our ball. Nice little white circle. Now we need to add a couple components. We're going to need a rigid body. So I'll add a rigid body 2D, and we're going to add a circle collider 2D as well. If I zoom in, you should see the green circle around it. That's the collider that we have there. Now I want to turn off the gravity scale. Just set that down to 0 and set the angular drag down to 0. We want everything on 0. And I'll set the collision detection to continuous. This thing's going to move semi-fast. I'm also just going to go down to constraints and freeze the rotation. Probably won't matter, but we don't really need the ball rotating. It's just supposed to bounce around. Now I'm going to create a prefabs folder and just drop the ball into there. Keep all of our prefabs in this folder. We're only going to have 3 or 4 maybe, so it's going to be a pretty small folder. All right, now we've got our ball, and I want to set up a way to launch the ball. Now, if you remember in the previous one, you just kind of click, drag, and it would draw a little arrow in the way that it was going to fire, and then release. So we're going to set that up, and we're going to create a new script. Let's go to the scripts folder. Oh, we don't have one yet. Let's create a scripts folder in the root. Name it scripts. And here I'm going to create a script named ball launcher. And we'll open that up in Visual Studio or whatever your code editor is. Here we go. We've got our script, and I think we'll get rid of start for now, and we'll get rid of this comment on update. We don't need that. And then I like to mark my methods that are private, just private explicitly, so I'm going to add that and then clean up the formatting with Control-K, Control-D. Now, we want to look for the mouse button going down, and we're going to use that as a start point for dragging. Now, this would also work fine with touching. If we just use the mouse one, though, it should be good on mobile as well. So we're going to do an if statement. We'll say if input.getMouseButtonDown. So this is only going to be true on the first frame where they start to click and drag. And it's going to be button 0, which is just the left click. So if that's true, if they started clicking, then I want to call a method called startDrag. And I'm going to pass in a position to this startDrag method, but I don't have that position yet. So let's just say world position. And we're going to create it just like that. But let's define this world position. I want this to be the place in the world where I've clicked. So basically I click and I need to convert that screen point of where I'm touching and clicking to an actual world 3D vector. So to do that, I'm actually going to go up above here, above the if statement, because I know I'm going to use this for a couple different things. Not just for when I click, but also when I'm dragging and when I release. So we're going to do this. We'll say vector3 world position equals camera.main.screen point to world, or screen to world point. That's what it is. And then we'll give it input.mouse position. So this is going to give us the exact point where we clicked. And this is almost good, but we actually need to move the point back a little bit because I don't want the thing right on the camera. If we look in the editor, let's just go take a quick look. So if we look at the ball, it's at whatever this is, close to 0 and 0 on the Z. This is the part that matters. And if you look at the camera is at -10. It's actually pulled back. If we go to 3D view, you can see just have this nice square view, and the objects are kind of in front of it, at the 0 mark instead of at the -10 mark. Now, if we do the click right there, it's actually going to give us the -10 on the Z. So we need to move this position back to 0 on the Z. Now, to do that, a couple different things I could do. I could just manually set it to 0, or I can just do plus vector3.back, which is, if you look here, it's 0, 0, -1 times 10. So this is going to give us that position, and then it's going to add in 10, or -10, sorry. And then that is going to move the object. Oh, yeah, actually, that would go the wrong way. So we'll multiply by -10. So this will give us a +10, and it's just going to move that object right back. Again, we could also just set the Z position of this world position to 0. That would fix it as well. But then, I guess it's exactly the same. It doesn't matter. Okay, so let's generate our start drag method. So here I am. I've got the world position. Now I need this method. I'm going to hit control period. Just hit generate method. And in here, the first thing I want to do is just cache the start position. I want to cache where they started dragging. So I'm going to say start position equals world position. And then I hit control period and generate a field for start position. You see here I got a vector3 now for my start position. And I'm not going to do anything else in here just yet, but we will be adding to it soon. Now, I also want to check to see if the player continues dragging. So I'll say else if input.getMouseButton 0. So this is if they held down the mouse button. Then here I just want to call something called continue drag. And again, I'll just pass in that world position. And let's generate that method. Now in here, we're just going to set an end position. So say end position equals world position. And again, we are going to be expanding out these methods a little bit in just a second. So don't worry about why are we creating these when they're only doing one thing. They're going to do a little bit more than this. But before I go on, I want to also get in my end drag. So let's do that. So we'll say else if input.getMouseButton up 0. Then we'll do end drag and drop in the world position. And we may not even need the world position here. Yeah, let's let me think for 1 second. Yeah, we don't need it. We don't need it. Because we're gonna have the end position already from the continue drag. When we release, we still have that same position. So end drag, we're just not gonna do anything yet. Well, actually, no, let's do it now. Let's make this ball launch. So we're not going to do the visual part first. We'll do that right after. Let's make the ball launch in the correct direction. So to do that, we need to figure out the direction that we want to launch in. So we'll say vector3 direction equals endpoint minus start point, or start position. End position and start position. And then we'll normalize that vector. So we'll just say direction.normalize. This will actually just change the vector and make it normalized. Or the alternative would have been to do vector3.normalize on the result there. Both of them do the exact same thing. Well, one of them changes the existing vector, one returns back a new vector. This is the one that changes the existing vector. Now we need to spawn a ball and make that ball just go flying up in the correct direction. So let's reference a ball prefab. Let's go up here and we'll start this off as a game object. So we'll do, well here, serialize field first because we want to be able to edit this in the inspector. And then we'll do private game object ball prefab. And pretty soon we're going to change this to be a ball, not a game object. But let's get it spawning first. So to do this, we'll say var ball equals instantiate ball prefab. And then we want to do it at this thing's position. So we'll just say transform.position. And for the rotation, we're not using that overload, we're using this one. We're just going to do quaternion.identity. So we're just going to spawn a ball where we are, wherever this ball launcher is placed. And then we want to add some force in the correct direction. So we'll just say ball.getComponent rigid body 2D. dot add force, and then we'll go in, well, we actually want to go in the opposite of the direction, so we'll do negative direction. And I think we're good. So this is going to give us the direction opposite of what we dragged. So if I drag down and left, it's actually going to shoot back out that way. It's kind of like you're pulling it back and then it launches out the other way. So it's going to go the opposite of whichever way we pulled it. Let's save this off. And I want to jump over to the editor now and create the ball launcher and just get it going and launch some balls. So let's create another game object. Again, I'm going to go to 2D and I'm going to make a sprite. I'm going to go back to the search and choose a knob again. This time I'm just going to color it. I'll go with like a green. I think green is the color I used before. And I want to go back to 2D mode. Right now I'm in 3D mode in my scene view. Click the little button to go back to 2D mode. Hit W to move to the move tool. And I'll just drag this down here somewhere. Now right now my scene view and my game view are a little bit weird. They're not really in a mobile size. So I'm going to go to the game view and change the free aspect over here to be, I think, what do I want? Oh, my other aspect ratios are all missing. Here, let's just create a new one. I'm going to do the one that I think my phone's on. So 2560 by 1920. That's actually not right, is it? Well, we'll fix the aspect ratio. Let me hold on. Let me look at my other one. So I'm in 16 by 10 portrait. I don't know why that's not showing up here. Oh, I do know why. Here, let's do this. Go to File, Build Settings, and if I switch over to Android, because that's what I'm building for anyway, you can do this on iOS as well, but switching over there should give me the correct drop-down options so that I can see the common mobile resolutions. Let's let that finish importing. All right, now let's try it. Yep, there we go. Now I've got my portrait 16 by 10. Perfect. So now I've got my ball launcher right here, but I haven't added the script, and I've got a ball up here. So let's add the ball launcher script and rename this thing from new sprite to ball launcher. And then we do have a prefab for our ball, so we'll just assign that right here. Save our scene, hit play, and let's see if it launches. So I should be able to click, drag back, and release. And I did see a ball up here. And the ball is moving very, 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 very slowly. We're not adding much force at all. But you can see it is moving. It's spawning and it's moving. So let's stop playing. And let's take a look at the ball. So our ball, we want to constantly move at a, I said that a little weird, but a constant speed. We don't want the ball to speed up or slow down in this game. It's just going to bounce and continuously, just go at the same speed. So let's go into our scripts folder and we're going to create a ball script. Then we'll open that up. And our ball script is going to be responsible solely for keeping the ball going at the same speed. So in our start, well, actually, let's get rid of start. Let's add an awake. So in awake, let's say awake, enter, AWA, enter, does it. And we're going to say rigid body 2D equals get component rigid body 2D. And then we're going to generate a field for that. Oh, it doesn't want to let me generate, so we'll just type it up here. We're going to make a private rigid body 2D. Name it rigid body 2D. And right here you notice the little green underline. It's saying that it's hiding the component that's already built in. And that is intentional because the component that's built in is supposed to be deprecated. It'll eventually go away. So we'll just add the new keyword. And that'll get rid of that warning there. Just says, hey, we know what we're doing. We're just putting this here because eventually in some future version of Unity, the built-in one will no longer exist. So we're just going to cache it ourselves. Now I'm going to clean up that formatting real quick. Control-K, Control-D again. Get rid of that extra space. And then get rid of the comment and add the word private here. Again, that doesn't make a difference. It's just to keep it nice and consistent so that everything's tabbed in the same. All the private things are just marked as private. Now here we just want to set the velocity of our rigid body to be the same every frame. We want to keep the direction, but make sure that the velocity is never changing. So it's never slowing down from a collision or over time from gravity or anything else. Nothing should be able to affect it. So we'll say rigid body 2D dot velocity equals rigid body 2D dot velocity dot normalized times, and here we're going to add in a new variable. I'm going to call it move speed. And we'll generate that field, and it's going to give us the wrong type. It's going to give us a vector2, but we really want to float. And we need to give it a default value. I'm going to go with 10. Now for this one, I want to add the serialized field attribute as well. So that way we can modify the speed of the ball just on the prefab. Turn it up and down as we need. And I'll remove those extra using statements, that extra white space at the end, and save. And then we'll go back over to the game, select our ball, make sure we get that ball script on there. And there we go, we've got our move speed of 10. Now I'm just going to apply the prefab. If we don't apply it when we instantiate them, they won't have this script on them. There we go, hit play, and let's try launching again. Look at that. Balls are flying off in the opposite direction of where I drag. If I drag up to down, you see it went down, down to up, and so on. So there we go, we're launching the balls. Pretty cool. Let's get the indicator working now so that we can kind of preview which way we're going to launch our ball. Now for this, I want to add a new script to the ball launcher. So let's just create another C# script. And let's call this launch preview. It's just going to be the thing responsible for showing us that line and letting the player know kind of where the ball is going to fire. Now we'll open that script up. And we're going to use a line renderer to draw this line to show to the players. So we're going to need to cache a reference to one. So here I'm going to add an awake, and we'll just say line renderer. Just like that, hit escape to get rid of the autocomplete, equals get component line renderer, and control period to generate that field, control KD to clean up that formatting a little bit more. And we can get rid of start and update. We're not going to need either of those. But we are going to need a couple methods here. So I want to be able to just set the points of this line renderer. The whole point of this script is just going to be to draw that line and make sure that it's in the right place. So we're going to create a public method, public void, and we'll call this set start point. And here we're going to give it the world point. So we'll say vector3, and I'll just name it world point. And then we need to cache that world point in here. So we'll say drag start point equals world point, and we'll generate a field for it. And then we're going to set the position on the line renderer. So we'll say line renderer, line renderer dot set position 0. So this is going to be the first point of the line, and we're going to set that to our drag start point. Now I want to add another method for setting the end point. So say public void set end point, and we'll do a vector3 again, name it world point, keep it nice and consistent. And then here, well, we actually don't want it to be where they're placing it. So if you think about it, let's just go back to the project for 1 second and take a look. So when I drag here and I start to pull down here, the end point shouldn't be here. It should actually be the opposite. It should be way up here. So I need to make sure that I'm not just using the end point, I'm using the opposite of the end point in that direction. So to do that, we're going to calculate out our final point. We'll say vector3 final point equals our point, or our world point, sorry, world point minus drag start point. Then we're going to add that. So this is going to get us our offset. This is like, think about it as a zeroed out offset. So actually, let's call this point offset. I like that better. And then to get the actual point that we want to use, we'll just take that offset, and then we're going to add that to our existing or our current position. And our current position we'll get with just our transform position, because we're going to put this on the same game object. So we'll say vector3 endpoint equals our transform.position plus the offset. Then we'll just set our line renderer point. So do line renderer.set position. Type that wrong. Set position. And we're going to set number 1. So this is the second point. And we're going to set that to our endpoint. Good. Let's save that off. Get rid of all that extra spacing, the unused using statements up there. And then hop back over to Unity. And I'm going to go to the ball launcher, and I'm going to add this launch preview component. So just once it's done compiling, drop that right on. And then we need to add in a line renderer as well. Because remember, we are trying to access a line renderer. Now, to make the line renderer visible, I'm going to give it a different position. Let's see. Right now, it's in 3D space. So if you look here at the second position, it's actually at a Z of 1. That's not really going to render because it's just going straight back. So let's give it a Y position that's greater. There we go. Just drag that up just to see what our line looks like. Right now, it's a big purple mess. Not great. So let's adjust it a little bit. First thing I want to do is just turn down the width. So I'll go to like 0.05, get a nice little pink line. And then we need to create a material for this. So let's just go in and create a materials folder. And then in here, we'll create a new material. And we'll just call this line. And I'm not even going to assign a texture to it yet. We're just going to create the material. We'll do the texturing later. Now let's go back over to our ball launcher and just assign the material under materials. But here, actually, we really want to expand this out and replace this one. If you just drop it on there, it's going to add it as an additional material. There we go. So now we've got a line. We can turn that into a dotted line or something else by editing the texture later. All right, now let's jump back into code and hook that launch preview script up. So I'm going to copy launch preview and go into my ball launcher. And here I'm going to add a private launch preview, and I'll name it launch preview. And then, oh, we don't have an awake, so let's add an awake and let's cache this launch preview. So say, private void awake, launch preview equals get component launch preview. So this is just getting that component so that we can access it and tell it to do things to give us a preview. And remember, we may want to do all kinds of crazy things with this preview. We might want to animate it, make it have some particles or whatever else. So it's really good to keep it separated and keep it out of this ball launcher. The ball launcher should be really responsible just for launching balls. In fact, right now it almost feels like it's doing too much because it's also handling the input. But I think it's small enough that we don't need to worry about it. So in start drag, we're just going to say launch preview dot set start point. Whoops. There we go. Set start point, and we'll give it our start position. And then you may have guessed, but in continue drag, we'll do launch preview dot set end point and give it our end position. Now let's try that and see what's wrong with it. Come back into here and we hit play. And we start to drag. See, it's definitely not right. We're not starting our point right here, which we need to be. So let's go back in and take a quick look. What we actually need to do is change this out. We don't want to pass in the end position itself. We want to get the direction. So here we're going to say vector3 direction equals end position minus start position. And then we're going to give it our transform.position minus the direction. Now let's save this and try one more time. This should give us our line in the correct point. Oh, it's still not right. What have I done wrong? Something is definitely wrong. 1 second. Oh, I see the problem here. I said that we needed to pass in the start position for our start point. That's totally wrong. We need to give it our transform position. The start point should be wherever our ball launcher is for this line preview. Now, it's not our start drag position. This is the start point for our line. So it's important to remember that these, like end position and end point, are not the same thing. This is the drag position. These are the actual line positions. So actually, I'm going to rename these. So I'm going to call this end drag position. By the way, it's F2 to rename in here. And it just automatically catches all of the instances of it. There we go. That should be better. Let's give this a try. So now I click, I drag, and I get the line just as I expect. And it doesn't matter where I am on the screen. I still get the line in the opposite of whatever I dragged. There, and now I can launch balls in whatever direction I want. And also I can see how far I've dragged because the distance of the line is going to grow. And I could just, click and drag on this guy too if I wanted to. But when I was playing, I noticed that that's not really how I played it. All right, so now we can launch balls and they go flying. There's nothing for them to hit though. So let's stop playing and let's just add in some quick walls. To do that, we'll go to the scene view and I'm going to create an empty game object. Reset the transform position to all zeros and just name this walls. Now under here, we'll just right click, create some 2D objects, make some sprites, and I'll call this, whatever, left wall. And I need a sprite that's going to work to cover and just make a block here. So if I went to sprite and maybe I choose one of these, like UI sprite or input field background, you'll see that if I stretch them out, they get deformed and kind of weird. Now I could zoom out and just scale them so big that the distorted weirdness is off to the side. That totally works. It's not a problem. In fact, I might just do that. The alternative would be to pull in a single pixel as an image and just use that as a sprite. And since I'm going to need that for my blocks anyway, let's just do that. So let's create an empty single pixel. So here we are in Paint with just an empty new project. I'm just going to hit resize, set the pixel size to 1, hit OK, and save it. Save as. We'll make it a PNG, and I'll call this white dot, and I need to put it into the correct folder, assets, and we don't have an art folder, so let's create an art folder. There we go. I've got a 1 pixel by 1 pixel little dot now in the project, and I can use that as the sprite. So here we go. Go select it. See, it's on sprite already, so we're good to go. Now I can just select that left wall, change it over from input field to white dot. There we go. And you see it did disappear because it got a little bit smaller. But if we zoom in, you can get a good look at it and just kind of scale it up. There we go. Now I've got a nice little white wall here on the edge. And here, let's pull these side by side. I think I want to grab it and just drag it over just a little bit closer to the edge. There we go. Now I'm going to, oh, do I want to resize it? I guess I don't really care if it's a little bit too big, like I said. But I do need to add a collider. So let's add a box collider 2D. And that should just line up exactly. You should see the green right there. It's kind of hard to see in this picture, but there's a green outline around the bar. You should see that on yours. Now I'm going to duplicate it and hold control and just drag it over to the right. And I'm going to let go of control because that didn't quite line up. There we go. And now I've got a wall on that side. And I'll name this right wall. And I may want to adjust it just a little bit. It seems like it's just a little off. Whatever. Close enough. Now I need a top wall, so I'll duplicate again. And drag this up to the top center. And I'm just going to adjust the scale. So I'll cut that, put a 6 there, and paste it right here. So now I have a nice long wide one. There we go. I've got a nice little box area. Perfect. I'll name this top wall. And again, it doesn't really matter if they're going off the edges. This is what the player is going to see. You could adjust it though and line it up perfectly if you really want to. So now I've got these box colliders in. I'm going to save, hit play, and let's launch the ball and see what happens. Bam! Oh, look at that. It just kind of flies up and slides and then bounces back down. Not what we want at all, right? In fact, here, let's do a couple. Look at that. It's an interesting little behavior, but it's not the behavior that we're trying to achieve. So we need to go in and create a new material, but this time it's going to be a physics material. So I'm going to right click, and I'm just going to do this in the root, and we're going to go down to physics material 2D, and I'm going to call this bouncy. We're going to set the friction to 0 and the bounciness to 1. Now select all of these walls and drop the bouncy right onto the material right there. That was a physics material. This is on the box collider. Make sure you're not trying to drop it into the sprite renderer material. And let's play again. Look at that. We've got a ball bouncing around. I can launch multiple balls. They'll bounce all around. Now they are hitting each other, and I don't want that to happen. So let's stop playing, save our scene real quick, and go to Edit and Project Settings and Physics 2D. And right here you'll see we have a grid where we can specify what things collide with what other things. And we don't have a special layer yet for our ball, so we're going to need to create that. So let's go back to the ball, go to Layers, and hit Add Layer. For layer 8, I'm just going to type in ball. Now, it's important to note that adding this layer did not assign it to the ball. So we need to go back to the ball again. In the layer dropdown, we should see ball finally. Select that and then apply the change. Now if we go back to our physics settings, so edit, project settings, physics 2D, we can now uncheck the ball colliding with the ball. So right here is the matrix showing balls no longer collide with balls. It collides with everything else, totally fine. We're really just using default, but we want to make sure that it doesn't collide with itself. So let's save, hit play again, and now if I launch multiple balls, they should not bounce off each other. See, they're going right through each other. You can kind of see it in action. But our balls are flying around, they're bouncing, and eventually they just get down here and keep falling forever. Not quite done, but we do have a ball launching system now, and we have walls that we can bounce off of. So all right, now that our ball is bouncing, let's give it some targets. So I'm gonna stop playing, and we're gonna create another game object. Again, we'll go to 2D, create a sprite, and here we're gonna use that white dot again. And we're gonna make this bigger. We're gonna turn this into an actual block. So let's find the block. I'll zoom out a little bit. I'm gonna go to the scale tool, and I'm just gonna scale this sucker way up. And yeah, let's keep going. I think I want to round a value of, let's just type in 60. I think that's about the size that I was using before. So now I've got a block that's the size of 60 by 60 using that white dot. I'm gonna rename this to block. And then I need to add a collider. So let's add a box collider 2D. That should line up exactly. There you can kind of see the green outline right around it. If I turn off the sprite renderer, there you can see the green. So we've got a block now with a collider on it. And let's move that block up here. And I'm just gonna play and bounce off of it 1 or 2 times. Just make sure everything's good. There we go, we launch, try to shoot up into there. Yep, kind of worked. Now you may notice that this one didn't really bounce right. It's because we didn't set that material here. So let's stop playing, add that bouncy material, play again, and see how it works. Go if my aim's okay. There we go. Look at that. So I'm able to bounce off these blocks. Should be able to get up in there and get above them. Oh, my aim is terrible, but here we go. Cheats, right? There we go. I got up there. Anyway, we need to create multiple of these blocks, but they also need to have some text on there that shows how many hits are left and then die after the hits. So before we start spawning blocks, let's create a block that actually works where it counts down its life and then disappears when it's done. So to do that, we're gonna add some text. But I never like to just use the built-in text, and we're gonna use Text Mesh Pro. Now I'm in 2018.1, so we're actually gonna do this through the package manager. We'll go to Window, Package Manager, go to All, and we're gonna go down and select Text Mesh Pro. And then just hit install. Which takes a couple seconds, but you'll notice that it's not actually putting anything into the project view. It's putting everything into that packages folder that's there now as of 2018, and it's kind of keeping the project view at least a little bit cleaner. It feels a little bit more like a NuGet package for somebody who's used to C#, where it's kind of adding the references without cluttering up the whole project. So let's close that off. And now I want to go right click on my block, go to, where is it, under UI? Or is it under 2D? I can never remember. We need a, not a UD, not 2I, 2D. Let's just add a game object under it. I can never remember where that option is. And then here we're gonna add a Text Mesh Pro text, not the UI one though. And I did get a pop-up here, so you're gonna see, as soon as you try to add a Text Mesh Pro font, it actually does need to pull in some assets. So it needs to pull in this TMP Essentials. So I'm gonna hit that button. And this is just going to get those fonts that I need and the files that are actually part of the project view that have to be there. So now I've got those. I've got a Text Mesh Pro text here, and I'm just going to put a number on here. I'm going to put, whatever, 99. It's a nice big number. And then I want to get this thing nice and centered on my block. So let's see. Oh, it probably is centered, but it's white right now, and we're drawing on a white one. So let's change the vertex color here to black. Let's center, and auto size. I'm not sure why I'm not seeing anything. Let's save and hit play. And stop playing. Oh, okay, here, let's select the game object for the text. I'm gonna rename this to text, and I'm gonna hit F. And you'll see here, it actually zoomed out. The problem is that my text is there. It's just giant. Look at that. That's our cube, or our little block, and this is our text. So with the text selected, I'm going to switch to the scale tool and just scale this thing way, way, way down. Not so far that it becomes negative, but nice and small. I'm going to hit F to zoom back in. There you go, get it down to a good size. And then let's get rid of that Y position offset so it's nice and centered, and the X position. So part of this is just that because that block has to be scaled up so big for the visual effect, we just need to scale that text back down to match and kind of compensate. So now we've got that there, and I'm going to shrink this in too. Just pull this in and kind of make it match. It doesn't really matter, but I prefer it like this. There we go. Cool. So now we've got a text on our block, and we need to add a script next. So let's go into our scripts folder and create a block script. We'll open that up. Now our block is going to need to access the text and the sprite renderer on our object. So I'm going to make a private sprite renderer. I'll call it sprite renderer. And then a private, and do tm pro dot, and here I'll do text mesh pro, and I want the one that's not the UGUI one. We're not doing this in the UI section. And we're going to name this, we'll just name it text. I think that's good. And I'm going to actually get rid of the tm pro dot and then hit control period and add the using for it instead. So it's just up here as using tm pro. I'll just simplify it there, and then I won't have to recreate that or re-add that when I do the awake. So let's add an awake method now. And here I want to cache these. So I'll say sprite renderer equals get component sprite renderer. And text equals get component in children text mesh pro. This is going to get our sprite and that text object so we can update the number of hits and adjust the color in there. So let's add a method to update the visual state. So we'll say private void awake. Not awake, we already have an awake. Update visual state. There we go. And here I want to set the text to the number of hits remaining and set the color based on the number of hits remaining. But we don't have a number of hits remaining, so let's add that. We'll do private int hits remaining. And here we're just going to say text.setText. So this is how you set a text mesh pro text value. And we'll say hits remaining .toString. And then we want to set the color of the sprite. So I'm going to say sprite renderer.color equals color.lerp. And we're going to keep this pretty simple. I think ideally we would want to have a whole color system that's responsible for giving us the color based on the number of hits. But for now, like I said, let's just keep it relatively simple. And we'll go from color.white to color.red. And the value that we're going to use, so we're going to go somewhere between red and white, and we're just going to do hits remaining divided by 10. So if we have 0 hits remaining, it's going to be like white or solid white. If we have 1, it's going to be just a little bit red. If we have 10, it's going to be solid red. And if we have more than 10, it's going to stay solid red. So I think that's a good starting point for a coloring system. Now we need a way to set the number of hits. Let's just default it to 10 for now. Or actually, let's default it to 5. Something relatively small. And clean up that formatting, remove those extra using statements and that white space while we're here. And then we need to deal with hits. So we're going to add a collision method. Say on collision enter 2D. It's this one right here. You just hit enter. And it doesn't matter what hits it. It's always going to be a ball. So we're not even going to look at the thing that's hitting it. We're just going to reduce the health. So we'll say hits remaining minus minus. It's going to take 1 off of our hits remaining, or our health essentially. And then we're going to, well, if our hits remaining is greater than 0, we'll update the visual state. Otherwise, so if our hits remaining is 0 or less, we're just going to destroy the cube. There we go. We'll just destroy this block. Now, ideally, we probably want to pool these and reuse them if we're doing this on mobile, just so that we don't get any extra garbage generation. But we're going to skip past that right now. If you don't know how to use pooling, I've done a couple videos on it. Just go check one out. It's really, really simple to switch that over to a pooling system. In fact, we'll be doing something similar to that with the Ballz shortly. So we've got our collision here. We're not updating the visual state though when we enable our object, so let's do that as well. I'm going to copy this, and here I'll just say in awake we'll update visual state. So they should all come in as a 5 and then take some hits and then blow up. So let's save, go back over to the editor, double check that our block has everything on it that we need. So it has a box collider, does not have that block script, so let's get the block script on there. Save the scene, hit play, and we should have a block now with 5 that's partially reddish. Oh, it didn't turn red. I wonder why. Let's see. Let's hit it once. Oh, so the hits are working. It is taking them. It's counting down, and this last one should finish it. Oh, come on. Let's see. If I can aim, it'll finish it. There we go. It took out the block. So I did kill it. I'm not sure what happened with the color. Oh, I think I needed to add an F right there. The problem here is it was dividing an integer by an integer, and it's just rounding down to 0. Putting the F there tells it, hey, treat these as floats. There we go. And then we can get the decimal points. So now it should get progressively lighter as it takes hits. There we go. And then when it dies, it goes away. Perfect. So now we've got a block that we can hit. Now let's set up a block spawner system. So I'm going to right click in our scripts folder again, create a new C# script, and I'll call this block spawner. This will be responsible for creating our initial blocks and all of the blocks after that. So every time we fire, our balls fire off, they hit things, and then we get new blocks once they've all returned. So this is the job of this thing is just going to be to create blocks, basically. So we don't need a start. I don't think we need an update. We can get rid of both of those. We do need a block prefab, though. So let's add a serialized field, and we'll do private block prefab. This is just going to be that block that we've just created. And then, well, let's create an onEnable method. So do onEnable, and we're going to loop and spawn some initial blocks. So I'll do 4, hit tab a couple times, tab over to the length, and I think I just want to do 3 rows to start. So I hit enter after typing a 3. I'll call spawn blocks. That seems good. And then we'll generate that method. So spawn blocks is going to spawn a row of blocks. Actually, let's rename that. Spawn row of blocks. So it's going to spawn 1 row, and we're going to do that 3 times. So to spawn a row of blocks, let me think. Well, we need to loop over however many columns that we're going to use, and then I'm just going to randomly decide whether or not to spawn a block in each spot. So I'm going to say 4 and tab, 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 and here I'm going to say play width. It's going to be like the width of our play area. And I'm going to generate a field for that, and I think I'll set that to 8 for now. I want to be able to adjust it though, so I may make it a serialized field later or something, but for now I think 8 is probably good. Just leave that in. Now we're looping over each spot, and I want to do a random check to see if I want to spawn something there. So I'm just going to say if unityengine.random.range, and we'll go like 0 to 100 is less than 30. Or less than or equal to 30. So we got about a 30% chance of spawning a block in each spot. So if that's true, if we roll a number 30 or less, then we want to create a block. So say var block equals instantiate. And we're going to do a block prefab. And then we want to figure out a position. So I'm going to call get position. And I'm just going to pass in I. Now we're going to generate that get position method in a second. And then we'll do a quaternion.identity for the rotation. We don't care about the rotation at all. Now I want to generate that method, so I hit control period and just let it generate a method for me for get position. And then here, we're going to set our position based on the offset there. So the first one will be at like the initial position of this thing, and then each one after that will be some number of pixels or units over from there. So say vector3 position equals transform.position. So we'll start off with our transform position. And then we're going to add something to it. So say position plus equals, we'll do vector3.right times I. So for 0, this will be a 0. We're not going to add anything at all. For 1, it's going to be 1 meter over. and 2 it would be 2 meters over. But I don't want it to be exactly that number of meters. I want to be able to adjust that. So I'm going to say times distance between blocks. And we'll generate a field for that as well. And I think the value for that is going to be, what is it, like 60? Or, let me think. No, it's tiny, not 60. That would be huge. It's going to be around 0.6 or 0.7. I think we want this to be 0.7f. But notice here, it also generated it as a vector 3. It should be a float. It always happens if you're multiplying vectors and you generate a field automatically. It always picks a vector instead of a float, which I guess makes sense for the system, but it's not what we want usually. So here, after we calculate out that position, I'll just return the position. It's important to note too, we're going to reuse this distance between blocks. Oh, I didn't add an S. We're going to use that on our blocks for the Y offset too, when we move them down. So this should spawn me a block randomly, or some number of blocks per row randomly. Now I want to set the health of these blocks too, or the number of hits. So I'm going to say, what do I want to do here? Let's say int hits equals, and I'm going to pick a random number again, Unity engine.random.range, and I think I'll go from 1 to 3, and then we're going to add in I. So for the first one, the first row will be 1 to 3 hits per block. The second row will be 2 to 4 hits. The next row will be 3 to 5 hits, and so on. It's just going to keep going up on the number of hits per block, basically. I think that's, oh wait, not times I. Not plus I would make it stronger as I got over. I want to do this plus rows spawned. And we're going to create a rows spawned integer. So hit generate field. Make sure you don't hit rename. Hit generate field. And then this is going to get incremented. So we'll do plus plus right here too. So what'll happen is we'll increment it and then add that on there. Or we'll add it on and then increment it. So the next time it's bigger. Now that we've got a hit count calculated out, we'll just say block.setHits, and we'll pass in the value of hits. And I need to generate that setHits method, so control period and enter, and then I'll go over it with the cursor and just hit F12 to go in there. And here we're just going to set our hits remaining to hits, and then update the visual state. Cool. All right. Now let's create this block spawner in here. So I'm just going to create an empty game object. Name it block spawner. And let's zoom out. There we go. And I'm going to put it right around here. Somewhere around where I think the first block is going to go. And we'll add that block spawner script to it. And then we need to get our block prefab. But I haven't made a block prefab yet. We have a block here, but we didn't put it in the prefabs folder. So let's take the block, drop it down to prefabs. Select that block spawner again and assign the block to the spawner. Save my scene and I'll hit play, and then when this enables we should see some number of blocks appeared. There we go, we got one block right there. Now if I disable and re-enable it, I got more blocks, disable it, more blocks, more blocks, more blocks, more blocks, and so on. And I just noticed a bug. So if we go back in here, our rows spawned should not increment every time we do a block. It should only increment every time we spawn a row. So I'm going to get rid of the plus plus there, and we're going to do it down here. We'll say rows spawned plus plus. That's better. But I also need to move down all those previous rows. So I need to get all of those other blocks that are active and just push them down a little bit. So to do that, we can just create a list. Do a private list of blocks spawned, and we'll initialize it to a new list. And then here when we spawn a block, I just copied this. We'll just go down here and we'll say block spawn.add block. So now we have a nice list of our blocks, and we can loop through that list right here and just move them all down. So whenever we want to spawn a row, we'll just move all the existing ones. So say for each var block in blocks spawned, and then we'll just move these things down. So say if the block is not equal to null, we will say block.transform. Oh, tooltips no good right there. Block.transform.position plus equals vector3.down times distance between blocks. This is just going to move it down. Now we do need to do the null check here because we need to make sure that we're not going against any blocks that have been destroyed We're not trying to move those. And we should really clean those up and get those out of this list, or come up with something a little bit less garbage collection generaty. But here I think it's still tiny enough, it's just not going to matter. All right, we're just creating a little list of blocks. We're never going to have a big enough number of these for it to matter, I don't think. So there we go. We've got a block spawner that should just give us some blocks. Let's hit play. There we go. I started off with 3 rows of blocks. I hit it again. I get some more. Hit it again. Get some more. Some more. I am getting 3 rows, by the way, per time. And that's just because we have it set to 3. If we go back into here and on enable, if we just set this to 1, you see it kind of act a little bit more like a regular flow. Let's just get rid of this existing block prefab that's in here too. Not the prefab itself, but the instance of it. So we don't need that spawned block there anymore. And I'll hit play and we should see the block, or the blocks just appear. There we go. And if I enable and disable it, we'll just get 1 more row. So this is more like the functionality that you're going to see when we're playing. Every time I click, it's essentially doing 1 more block spawn. And you can see it's also offset a little bit. There's a little bit of room to either add another block or maybe pull in those edges. And I think what I'm going to do is just stop. I'm going to pull this in just a little bit, and I'm just going to make these edges, these walls a little bit thicker for now. So just grab it and grab the X scale, just drag those out a little bit like that. Hit play. Let's see how that feels. Now we could do some calculation to figure out exactly where these things should be, but it's going to be quicker to just play around with it for a couple minutes, not even a couple minutes, a couple seconds, and just line them up. It's going to be good enough. It won't matter. There we go. Let's try one more time. There we go. Spawn some blocks. Spawn some blocks. Oh, looks pretty damn close. I think I want to go a tiny bit more to the left, though. Just a little bit. That's good enough. So save that off. Now we've got a block spawner. We've got a ball launcher. We've got blocks that we can destroy. The next thing we need to do is really just dive into our ball system so that we can shoot a certain number of balls. Those balls come back and return, and then when they return, we spawn new blocks. So let's go back into the ball launcher script here, and we want to create a list of our balls. So I'm just going to create a new private list. So there's a private list of ball. I'll call this balls equals new list of ball. And then we need a method to create some balls. So I'm going to go down to, probably right here, to private void create ball. And this is just going to be responsible for creating a ball and adding it to our list, basically instantiating and getting a ball ready in our pool. So to do that, we'll say var ball equals instantiate ball prefab. And actually, let's change this from game object now to ball. Said we were going to do that earlier. Let's just get that done now. And we're going to instantiate that prefab. I don't think we care about the position or the rotation, so we'll just leave it like that. We'll say balls.add ball. And then we want to mark balls ready ++. So what we're going to do here is create an integer that just keeps track of the number of balls that are ready and reloaded. So the ones that are ready to be fired. As we shoot them off, we'll decrement this. And then when they return back into our system, we'll just add them back in. And then we'll be able to shoot again once all of our balls are ready again. So there we go. We'll generate a field for that. And I'm going to move that up here away from the serialized field just to keep them organized and semi-clean. Let's get rid of that, the 2 using statements that aren't used there as well. So now we've got a way to create balls. And we need to actually hook it up to start creating some. So the first thing I'll do is just in awake, we'll just create a ball. So say create ball. Now you might be wondering, hey, we're not doing anything with these balls, so why are we creating them? Well, we're going to change that right here. So in end drag, where we were instantiating and setting the force of a ball, we're going to change that a bit. And instead, we're going to just pull balls out of our list. But we're going to do more than one as well. We can't just launch a single ball. Well, I guess we could, but eventually we're going to want to launch 2 and 3 and 4 and so on. So let's change this up, and we're going to turn this into a coroutine. So I'm going to say in end drag, I'll say start coroutine, launch balls, and then I'll generate the method for launch balls. And I'm going to cut all of this code and just paste it down in launch Ballz. Now I'm going to add a for loop here. So I'll say for each, tab, 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 ball in Ballz. And then we'll get rid of this closing brace and paste it right down here just so that all of this code is now in the loop. So we do want to get the direction. Really, now that I think about it, we don't really need to get that more than once. So let's just cut that and we'll put that right up here. So we're going to loop through each ball and then we're going to launch that ball. So we don't need to instantiate the ball because we already have the ball. So I can get rid of that. And we really just need to get the rigid body and add the direction. Although we do want to set the ball to active as well. Right now we're not disabling our ball, but we're going to soon. So we'll say ball.gameObject.setActive true. And we also want to set the position. We want to make sure that the ball is reset and launches from the position of our launcher. So we'll say ball.transform.position equals transform.position. So we're going to get the ball launcher's position. And this is not supposed to be a string return type. I just realized that it generated it wrong. This should be an IEnumerator. There we go. Much better. Now get rid of that space there. And it's giving me an error now saying, hey, we're using IEnumerator, but we're not, yeah, that's right. But we're not doing anything with coroutines here, so it's kind of blown up. And the error message is not really too helpful. So let's change it up, and we're going to add in a yield statement here. So say yield return new wait for seconds, and we're just going to wait for 1/10 of a second. So do 0.1f. So what's going to happen is we're going to loop through each ball. We're going to launch it, wait 1/10 of a second, launch the next one, wait 1/10 of a second, launch the next one, 1/10 of a second, and so on. Now let's see. If I compile, let's see if that error message goes away. If I've done something wrong here. Oh, okay, I see what the problem is. Now let me look at the error message one more time. I didn't notice this the first time. It's saying the generic type IEnumerator of T requires one type argument. The issue is that if you go up here, when I removed the unused using statements, it got rid of system.collections, which IEnumerator without the generic type is part of. So right now it's finding the IEnumerator from system.collections.generic, which requires those little brackets and a type in there, and that's not what we want. So we need to just re-add using system.collections. And then that should fix it. Yep, there we go. IEnumerator is no longer invalid or missing, and we're good. Now I also want to set our balls ready back down to 0 when we launch all our balls. Say balls ready equals 0. We could also just decrement it here, but we may as well just set it to 0. It's going to be 0 at the end. Now let's actually make us start with a couple extra balls. Here, let's just copy, create ball. Let's just do it 3 times. And I just want to see that we can shoot off all 3 of our balls and they fly off. We won't be able to, well, I guess yeah, right now we can still keep shooting them because we don't really have anything stopping us. So that's perfect. Save, go back in, hit play, and see if we get 3 balls firing off with a 1/10 of a second delay. Oh, we've got an error here. Object is null. The reason for that is our ball launcher. Remember we changed the ball prefab from type gameObject to ball, and that made it lose the reference. So we need to go to the project view and reassign the ball to the ball launcher in that ball prefab section. Now hit play again. I probably should have saved first, but whatever. Hit play, launch the ball, and there we go. We get 3 balls flying out. And, oh. So something's wrong on the, oh. Yes, I know what's wrong here. So notice when I keep shooting them, they keep resetting and just flying off the wrong direction. That's because the velocity on these things is not getting reset. So we need to also stop their velocity. But we're going to do that a different way. We're not actually going to go in here and change it. We're just going to disable the game object in a moment, and then that's going to stop the velocity of the thing. So let's go over to our scene view again, and we're going to add one more wall. I'm going to take this top wall, I'm going to duplicate it, and I'm going to zoom out a little bit, and then just drag it down here. It's going to be, right around where our dot is. And I'm going to call this ball return. this is going to just send the balls back once they hit this point. And we could leave this visually here. I could change it. Maybe I'll turn it into like a yellow line. That seems interesting enough. So you can pick however you want to do this. You could also just make it not visible, make it a dotted line, whatever it is. But we need to have something here that has a box collider that can listen for these balls hitting it and then do something. And actually, I want to move it down just a little bit because I want it to be below the ball spawning point right there. Okay, so let's add a script. We'll go to the scripts folder and we're going to create a ball return script. And we'll open that up. And here, let's see, we'll get rid of start and update, and we'll just add an on collision enter 2D. And we want to return a ball whenever this thing gets collided with. Remember, the only thing that should collide with this is the ball. So we'll say, well, we need to get the ball launcher. So we do like a find object of type ball launcher dot return ball, and generate a method on the ball launcher for that. And then we want to turn off the ball itself too. So we'll say collision dot game collision dot collider dot game object dot set active false. So that's going to turn off the ball game object. And here we're just telling the ball launcher, hey, this ball is now back and ready. So let's remove those using statements, clean up that formatting, get rid of the extra white space, and we're good. Now we could also cache this ball launcher. In fact, I'm almost inclined to do it, but yeah, let's do it. Let's do it. So I'll cut that. Let's add an awake. Awake right there, and we'll say ball launcher equals find object type ball launcher. Now, if I were doing this internally myself and not showing it to people, I may have skipped that part just because it didn't make a big difference. But since this is going to be public, it feels like it's just important to keep things as clean as possible, or at least as clean as possible without taking too much time. So now we've got our ball launcher returning the balls whenever the ball return is hit. Well, we don't really. We're calling return ball, but we're not doing anything in it. So let's go into there. And then for our return ball, really, let's see, what do we need to do? Well, we need to increment our balls ready. Do balls ready plus plus. And then this is a good spot to check to see if we've finished with our round. So remember, the round kind of ends when all of the balls have returned. So if they're all back, we can kind of proceed on to our next round. So let's do that. Let's say if balls ready equals balls.count. So this is the whole list of our balls. If all of them are back, then we want to, well, we need to spawn some blocks. So we need to access our block spawner. So we'll say block spawner dot spawn blocks. Now we don't have a reference to our block spawner, but again, we're just going to cache one down here in awake. So say block spawner equals find object type block spawner. And again, this is a pretty simple project with one scene, so find object of type is going to be the easiest and most ideal way to do this. And then spawn blocks, oh, it says does not exist. Let's see. Oh, it's because I named it spawn row of blocks. And it's also marked private. I'm going to need to change this to public. And then we'll go back and call this spawn row of blocks. There we go. By the way, that was just control space to just auto fix it. In Visual Studio, if it can find it, it's going to just fix it. So there we go. Now we're spawning a new row of blocks. And then the way that I've set it up, instead of putting in the power-ups that you hit to grab balls, we're just giving the player a new ball each time. So I'm just going to call create ball. Now we can change that later if you want, but for now I think it works. And I'm going to get rid of these 3 balls on startup and just cut it down to 1 ball. By the way, that's shift delete to just delete an entire row. And we'll get rid of that extra using system statement up top. And the last thing I want to do is move this return ball method because I don't want it sitting up there in the middle of my fields. It should be somewhere down here. It is public, so I like to keep it near the top. I think I want to keep the awake above it though, and then return ball there. And it's actually marked internal. That's just a side effect of auto-generating them. In this case, it's essentially the same as public, so I'll just write public, make it a little bit less confusing. But the only difference is internal stuff can't be accessed from another DLL outside of this. So if we were working with a project that had multiple assembly files, then we wouldn't be able to reference return ball from outside the assembly. But like I said, doesn't make any difference here, so I just made it public instead. All right, I think we might be good. Let's save, come back over to our scene. I'm just gonna save the scene too. I hit play, and let's launch some balls. There we go, we're in, we drag, we shoot, ball comes back. Oh, the ball is not returning. Okay, why is the ball not returning? Let's take a look. Our ball return script is not on here. Let's add the ball return script. I'm gonna do it while we're running. Ball return script. Bam! Now it returned, and now we should have 2 balls. Yep, and now we get 3 balls, but we're getting a new row every time. Look at that, and we can hit the rows, knock them down. I think we've got pretty much the core of the functionality of this game. Now, there's a lot you could do to really polish this thing up. You could add a lot of cool features, add some visual effects, maybe make the boxes actually explode and shatter apart, make the little balls a little bit more interesting than just a white dot. Oh, whatever you want to do. In the other game too, in the real one, I noticed that the ball launcher kind of picks a new spot along the line here, so you're not always launching from the center. Sometimes you're launching from the corner or whatever. Oh no, and I think we might have hit an error there. Oh no, I didn't. It just didn't spawn anything. Okay, cool. But I think you get the general idea of how to build this game, hopefully, by now. I think I'm going to cut this here. It's already a little bit long, and I think I've covered, like I said, most of the stuff. But if you have questions about this or want to see this expanded on a little bit, have some ideas, anything that you want to bring up, I guess, or any ideas that you want to add on to this thing, just drop a comment below, and I'll see about maybe continuing this, turning it into a slightly more polished game that, you know, you can come back in and actually build on and make a real game and release it or something. Anyway, thanks for watching. Don't forget to like and subscribe. Hopefully you've done that by now. We're probably about an hour in. Definitely hit the like and subscribe and share and all that stuff. And yeah, that's it. Thanks again.